have some of our eminent, renowned, and experienced scientists and researchers for sharing their insights on the impact of climate change over coastal flooding and for providing specific recommendations on the future direction under this specific theme. Before getting into the discussions, I'd like to introduce and welcome the chairman of this session, Dr. M. Rajivan sir, former Secretary, Ministry of Earth Sciences. Sir has contributed significantly in the field of...
I think the introduction is, you can avoid, you can save time. We all know each other. We know each other.
Okay,
we know
sir.
our horoscope very well, our horoscope. What we did, what we are not done, everything we
Okay,
know.
sir,
So I request you can summarize it, whatever you want to say.
Yeah, okay, sir, fine. So, and our co-chair is Dr. V.S. Prasad, sir, Director of NCMRWF, and our esteemed panelist, Dr. Anita Gera, Scientist Staff of NCCR, and Dr. S.K. Behera, Director of Application Laboratory, JAMSTEC, and Dr. K.J. Ramesh, former Director General of IMD, Dr. R. Ramesh, former and founder director of NCSEM Chennai, and Dr. Balachandran, Deputy Director General of RMC IMD Chennai. So with this brief introduction, I'd like to hand over the session to our chair. So our sir will take over the session.
Thank you very much. So we'll start. I think people are coming now. So as you know that India is the third worst affected country due to climate-induced natural disasters. If you really see the history of natural disasters, and we have a long coastal line, about 7,500 kilometers. And as I said in the morning, 260 million people are living, or 1/3 of Indian population are living in the low-lying areas within 50 kilometers of sea coast. And therefore, they are exposed to climate variability and extreme weather events. And there are about 130 towns and 77 cities, and 84 coastal districts are there. So, and also the largest and most dense coastal urban cities such as Mumbai, Calcutta, Chennai, and Visakhapatnam are hubs of critical infrastructure. And these 9 coastal states collectively receive more than 60% of India's foreign direct investments. And importance of coastal areas. And coastal area, what could be the causes of coastal flooding? These are general information. One is we all know about climate-induced sea level rise, because global warming is taking place, so there is a thermal expansion. The thermal expansion can give rise to sea level rise, and that's a climate-induced sea level rise. And also new studies have told, suggesting that vertical land movements, people like Prakash Chavan will know better. This is geological processes, and especially in urban cities, I think a city like Tokyo, it is happening, that's what I was told. Basically, it's natural as well as human-induced subsidence, so that also can cause kind of coastal flooding. And there's another new theory is coming out, is a compound flooding, basically from arises from storms causing extreme meteorological tides. Meteorological tide is nothing but superposition of storm surge and waves together, and heavy precipitation. If it comes together, heavy precipitation will really flood cities like Chennai and all. In addition to that, a storm surge also is there, means then you can expect a kind of a compound flooding can be expected. And also there is a threat due to increase in tropical cyclone intensity. If you really see the climate change projections in the coming years, what we see is there's a lot of uncertainty in the number of frequency of tropical cyclone, whether it will increase or decrease. But there is a little consensus on tropical cyclone intensity. When it forms, it is likely to be more intense. So if it's a tropical cyclone intensity, there is a consensus, so we should worry about that aspect also. So these are all possible coastal causes. And I will go very quickly to one by one. Sea level rise, if we have data from 1900 or so, and it is, we already got an observation about 0.18 to 0.20 meter rise in the last 120 years or so. And what is more important is years like El Nino years also can add more kind of a oscillated sea level rise, and rapid is called a rapid SLR. And the last point is very important. Data says that current state of sea level rise as measured by satellites is around 50% faster than what we experienced in the 1940s. So that means the sea level rise is not uniform. Sea level is not uniformly increasing. It is getting, the rise is getting oscillating. So that's number 2. Yeah, this is a subsidence. So there's a very good paper has come out recently in Nature, so which has discussed about the subsidence. But basically, it's a vertical land movements, including natural and human-induced subsidence in sedimentary coastal lowlands. And so if you assume that 2.6 millimeter per year is the last global mean sea level per year is the last mean sea level rise. But these coastal inhabitants are preferentially located in subsiding locations, so they experience an average relative sea level rise up to 4 times faster, that is 7.8 to 9.9 millimeter. This is much faster than the 2.6 millimeter. So basically it means that impacts and adaptation needs are much higher than reported global sea level rise measurement size. Next is compound flooding, which I mentioned is basically arises from storms, tropical cyclones basically, causing concurrent extreme meteorological tides, so basically superposition of storm surge and waves, and also heavy precipitation. If we come together, then we can expect a kind of a large sea flooding. This flooding can severely affect densely populated low-lying coastal areas. And in future scenario, in high emission scenario, the current concurrence probability would increase globally by more than 25% by 2100. So that is the climate change projections. And increase in tropical cyclones, as I mentioned that cyclone frequency, there is a kind of uncertainty whether the number will go up or not down. But there is a consensus that the intensity will increase in future, especially over Pacific as well as Indian Ocean. So the increase in tropical cyclone in intensity basically means a severe cyclone can give you more precipitation, there's a number of heavy rains, and also because storm surge, if you assume that all other parameters are constant, delta P doesn't mean pressure difference, more intense precipitation, cyclone means more delta P, and more delta P can increase the storm surge. So these are all additional factors which we need to. So what people are now doing is a kind of a dynamical flood modeling that doesn't only cater only to the climate change induced sea level rise. That's basically thermal expansion. They also consider many other factors, climate dynamical physical drivers such as tidal nonlinearity, storms, short-term climate variability. Short-term climate variability, I mean to say that's El Nino, the occurrence of El Nino and La Nina, erosion response and consequent flood responses. And what we can do now is basically the adaptation is more important, and for example climate resilient, flood resilient infrastructure is more important, and we need to really construct the kind of buildings and infrastructure so that it can withstand the coastal flooding. And last point, which of course our good friend Ramesh will be able to comment, is our government is really giving some kind of concessions, and they are going a little more reforms in opening up mainland coastal lane for commercial activities. Earlier it was 200. Earlier it was some 500 meter. Now it has become 200 meter. 200 meter. 500 meter. It has become 200 meter now. So that means we are allowing more coast to be used by public for commercial purpose. So that should be little worry. I'm not blaming any government or individual. So what we can do is we need to improve our forecasting system, flood warning system, and also we need to have some adaptation issues. We need to discuss it. And of course, there are not many people from disaster management wing from ours in this hall. But if we can, somebody can comment on that, it will be good. So I will, if you don't mind, I will request now. Prasad, you want to say anything more?
I feel honored to co-chair with Dr. Rajivan, and under his guidance, NCMRWF joined in coastal flooding things with the projects iFlow, Mumbai and Chennai, and we have done good work with along with NCCR, and my colleague Anita Jira is in NCCR working on this one, and another my colleague Dr. Ashit is there. He is also actively involved in the Bombay airflow. And under this Bombay airflow program, lot of AWS stations, very high density AWS stations are established, and radar also going to be established there. And all the data we are receiving, and we are able to give the very good prediction with improved prediction over the Bombay and Chennai region also. And the flood forecasting things, models, other things are done at NCMA, at NCCR, and we are giving the rainfall forecast or the region. And for that one, we have improved the city level forecast also. We have included 330 meters city level forecast also. We started that one. And at present, for that is getting developed for the city level forecasting. And at present, we are giving that a very high resolution 4 kilometer model from rainfall from the forecast. And further, to study the historical events, about 40 years reanalysis data set we generated. And that 40 year reanalysis, if you see that one compared to the ECMW of ERA 5 or any other models, it is able to capture extreme rainfall events very well. So to study the extreme events of the last 40 years, I think the IMDA reanalysis that generated at NCMRWF and also global reanalysis also were generated. These data sets are found very well, and in ISRO there are about 25,000 people are using the data sets and found it is very useful for studying the 40 years, not I will tell the last decadal variability of the flooding, and also decadal variability of the weather events over the India. That data set is found to be very valid and very good quality. And regarding the flow things, when we are doing urban flow forecasting, many institutes, many centers, they are putting the observation together. We found that using the high resolution observations, I think we need to do the quality of the systems. For example, AWS people are Bombay Municipal Corporation, they are establishing about more than 100 AWS stations, and NCMR study to use that quality of the data. I think there is a normal rainfall is getting, but we are getting extreme rainfall. The different changes in IITM, IMD, and these rainfall station, AWS station, they are giving the different observations. Mainly because these other centers, they're not following the WMO or IMD criteria in installing the instruments. So that variability, what we are getting very heavy rainfall, we are not able to use in simulation, because there is in observations, when we are putting this type of high quality observations, I think we have to take care of that IMD guidelines of establishing the instruments. Then we can give the better forecasting and better use that data. Otherwise, we are giving our forecast quality is improving, but still more further quality is improved, and verification and model development, the good quality observations are required. And I think when we are planning this one, I think we have to plan for the good quality observations, and standards of observation we have to be follow that one. That will give the flooding forecast, or also real-time flooding, not only the forecast, in real-time monitoring also the quality will improve, and that way that is more important. And this network from the Kolkata, and now we are going to Calcutta. Kolkata iFlow program is starting, and Dr. Ashrif is working with NCCR, working for extending this iFlow from Chennai, Mumbai to Kolkata. I think with that I will stop.
Thank you. Thank you very much. And so we'll go to the next panelist, Adida. Yes. You're running away?
No, she's on phone.
Yeah, you can start, please. Your presentation?
Yes.
Very brief, 10 minutes.
Presentation.
First one.
Thank you, sir. It is a privilege to present this MOS effort on behalf of MOS and NCCR. It's a great honor to present this. It's a teamwork which has been, effort which has been carried out by many institutions of all institutions of MOS as well as state governments. And I thank our director, Dr. Ramanmurthy, for giving me this opportunity. So I'll be presenting on the iFlows what the system is now in place is at NCCR, and then what challenges that we are facing and what we can, what my inputs would be for the recommendations. And so briefly, so having set the stage, I will not tell this, sir. You have already set the stage. So the iFlow started with iFlows Chennai when 2015, under the leadership of Dr. Rajivan, iFlows Chennai has come up when there was a great flood event, an unexpected flood event in Chennai, which was followed by iFlows Mumbai. So both of them are operational, and iFlows Mumbai was operational in about 9 months record time. So these things have, to just give an overview of what it is, we have, this is an end-to-end real-time operational early flood warning system. This has 7 modules. It starts right from rainfall, when the rainfall occurs, rainfall to runoff, to inundation, and then to what the impact would be, what is the vulnerability, what is the risk to the impact. So we call it an end-to-end real-time operational flood warning system. In this, we have, like, when we start with rainfall, we have weather models from NCMRWF, as well as some other. I will next talk upon the other things in my next slide. But when I say rain, it comes from operationally, it comes from NCMRWF 4 kilometer by 4 kilometer, and then it goes to a flood model, which is a hydrological model, and a runoff model. That's the flood module. It's a modular system. So the flood module computes the runoff and the inundation. After that, it moves to, it also has hydrodynamic model for the inundation from the flood when it spreads onto the land. That's a hydrodynamic model. And then we have a hydrodynamic model for the coastal thing, that is the storm surge, as well as the tide. We have another ocean hydrodynamic model, which gives its boundary to the flood model. So this is the architecture of the model. Once the inundation is ready, then it goes to the thematic data. That is the vulnerability, risk, and next 3 components, the vulnerability component, the risk component, and the dissemination component. So these components, what we have is all the local administration, the land use, all the infrastructure. When I say infrastructure, it is the roads, the railway network, everything, all the buildings, how many police stations are there. So all the critical network, everything is mapped. And then the elevation is there, the elevation of the terrain of both Chennai as well as the terrain at a high resolution, 20 centimeters resolution terrain taken from altimeter is available, which is translated into into the DEM. Then this is followed by the socio-economics, the population, the socio-economical data, which is called LTM was flown, sir. Radar-based, high-resolution DEM. Yes, sir. Complete for at 20 centimeters we have, but then we have made it coarse because our model is not that high resolution. We have made it 1 meter elevation levels, contours. So all these are input into a data integration module. So all these levels, all these socio-economic and physical, as well as whatever the streams are. Sorry. It's not working. Yes, sir. This is not moving. I'll put next. Can you move next? Yes. So all the river water streams, including the storm drains, each and every layer is considered, and then the bathymetry was not available for the streams of Mumbai as well as Chennai. So NCCR has taken up this exercise to go and measure all the streams and nalas of Mumbai. Sometimes there it was stuck, but all of it was taken care and included in the model. Next. So once the model is ready, we have a four-pronged approach for the system to be fail-proof, foolproof because it is an operational system. So when I say it is a 4-level forecasting system, first we take the IMD warning. Based on the IMD warning, IMD gives a color-coded warning for, say, Chennai. So Chennai, there is going to be a heavy rainfall or a very heavy rainfall. So based on the... Yes, sir. Validation also will come, sir. Parallelly, sir. Correct, sir. Yes. We have calibrated the model with previous event and then gone ahead, sir. So first step, we have the IMD SOP color-coded one. Based on that, we develop, we run the model, and the outcome would be inundation, and again comes to till the impact. So this is the first level immediate issue, and this is transferred to IMD and immediately issued. The next level is based on NCMR, WF, IMD, IITM, NWP centers. Right now, for the operational thing, we are using the real-time forecast from NCMR WF at 4 km by 4 km. Just in case, we are also doing, just in case to make it foolproof and to make verification, any system is lost, we want to see IMD 12 km, IMD 3 km WRF model also. We keep it in hand and we run it as a background. Just in case some system is not detected in one model. So we have IMD 3 km WRF model as well, and then IITM 12 km GFS model as well as a backup. And to validate also, if some system, what is happening if some system is not working, we have to go for as a real-time validation. Next step is we go with an observations. Like for Bombay, sir was telling 110 AWS are there in place. So we are getting it updated at every 6 hours. So every 15 minutes we get real-time transmission of the data. We are making a initialization every hour, and we are giving the output 6-hourly output based on this forecast, based on this observed rain. Just in case, because the administrator wants right now what is happening we want. Model is sometimes I don't want to, model is only 12-hourly model. Cloud burst, no. Yes, sir. Right. Yes, sir. Yes, sir. Yes, sir, I'm coming. Yes, sir. Yes. That is. Or
and also IITM is procuring 4 small radars of 100 km range, and IITM is procuring 4 radars. It was placed, model was placed some 4 years back because COVID and got delayed. So that too will be installed in.
I'm not undermining your work. It's excellent work. I'm trying to say that to make it complete, you have to do a little more.
Yes.
One is you have to assimilate data from the Dr. Radar, more or less simple. And you have to have the capability to capture cloud burst. If you cannot do that, this will not be sufficient.
So these 4 radars will give you additional data, so that then you are supposed to get data at every 1.25 kilometer or so.
Certainly it's a tremendous work.
And cloud-based, I think, if you
Small
can raise a
interruption.
hand, you can raise. I think no model will be able to pick up.
Small interruption.
Model. Observation.
Observation it will pick up.
Small interruption.
Forecast. At least observation.
For observation it will become.
Chennai we are trying, sir. Now, Chennai nowcast they are giving based on the radar nowcast for the next 2 hours. So we have started receiving the data. We are working on it, sir.
See, it's very dynamic. For example, when it rains, you find that there's plenty of rain, and from that you can say that where are this water will go. But when the people receive the forecast, your warnings, by that time additional rains will also will come. Well, rain is a continuous process. It will be go on coming. Yes or no? So you cannot freeze your data and say that now with the flood water will go this way, that way. The rain will still keep coming. So it's a really tricky issue, but then you may have to update it every hour probably, or
Not
every.
only the spatial extent, the most important aspect is the flood depth. You know, how much is the flood depth? So that is a very important. If you
Yeah,
have
of course they get
inundation depth you are giving.
yeah, they get a flood depth. Flood depth they get.
Once rainfall is changed, they can give that.
Other question came to my mind, you said bathymetry. From flood point of view, why bathymetry is important? I consider, as a physics wise, bathymetry is not very, flow into the ocean. So surface water is important, bathymetry also is important.
Actually, sir, what is happening is some of the, especially in case of cities like Bombay, the tidal influence is there and this runoff, it needs to go into the ocean, and many of these channels are silted actually. They are, every year they get silted. So their capacity to take this water out into ocean is reducing, and that has impact on the flood. So
Yeah, for example, unless you know the bathymetry, how you know whether river will overflow?
yeah.
How you know the river will overflow?
No, ocean surface is there.
No, I am talking about the rivers. There are rivers inside Mumbai
In
city.
Bombay, you have many channels.
No, she is talking about bathymetry of the rivers, not the ocean.
Ocean.
No, no.
Rivers and streams.
Streams actually.
Streams.
See, just want to give an input. There are private AWS in Chennai itself. So there is a site, KA Weather blog. So during the rain, if you just go and see it, lot of people give an input. Palavakam, 12 mm, there 10 mm, Taramani 1 centimeter. So they keep on giving the data. So you can have a look at that.
Yeah, the problem with the private people is they don't follow WMO rules. They put wherever is available. It may be on top of the 10 floor story building. So you cannot put rain gauge there, isn't it? You have to put somewhere in the ground. So IMD will be comparing a rain gauge with Meenambaga IMD observatory with a rain gauge of at about 100 meter. You cannot compare. So that's the problem. So we have been thinking of collecting all private players. Because IMD, SkyMet has put plenty of observation over Bombay. Plenty of observation. But question is, we don't know where they put, first of all, and what kind of observations, the rain gauges, and where they have put. We don't know.
Interesting part is, most of them are, amateur mets. So they run their models and also give the prediction also. Be very interesting.
My suggestion is let them do their job. Let us do our job.
But what I find one more, June, the month of June, early morning, 3 o'clock to 6 o'clock, Dr. Balchandran also will know. There was a rain in Taramani. I live close to Taramani. They gave the number early morning after the rain was 11.6 centimeter. They corroborated with IMD data. In 3 hours, 11.6 centimeter.
Some people do it very well, but who know about the meteorology, but otherwise people put on their own will. See, for insurance people, they need some rain data for insurance companies. They will put somewhere and they will take that data and do it. But that's not the way IMD does it, isn't it? Okay, so please, can you summarize it?
Next. So, next. So these are all different based on field data, based on different outputs that we are giving. Both the impact.
So still it is operational now, it is working.
Operational. This is all operational. Next one. This is the impact at street level that can be done. Who are direct to the numbers of including the numbers of the administrator at the same dashboard we can get, sir. Once the administrator opens it, all the details, how many wards are going to get inundated, how many people are there, what is the risk. So all the socio-economic data is getting into this. So shall I?
Yeah, I think you continue another 2 minutes.
As last slide, challenges and
Slide is not moving.
Please move.
Next one. Can we move from a flood warning system to a flood anticipatory system? That is for bringing in, not only we are just doing it 3 days, but then should we look at the season or the climate scenarios as well and put in into a thing? Then I have one risk analysis what has been opened today that can be used in this next slide. Just wait. Saji, next slide. Next. So this risk atlas is giving what are the places, things that we have already in place, protections from coast. So can we go there for climate change? Can we go integrate all this data? And what are the challenges? Can we come up with a framework? Because the brainstormers are here. I would like to put it and
There's just one
put it
comment.
forward for the next step.
See, it's a good work. I'm not undermining, very good work. But there are a lot more prone areas. It's not just Chennai or Bombay. In fact, whole Uttarakhand is more important. So actually, before going for anticipation 3 days before or 3 months before, you should focus this work to be completed in those vulnerable areas, like Uttarakhand and like elsewhere. That's more important. That's higher priority. Fine. See, flood is not just coast. Amity does it, no problem. Does Amity have a problem like this?
Actually, this is the task of CWC.
No, they will never do that.
One point only I wanted to add. Of course, in coastal cities you can just see apart from rain, like you saw in Delhi. See you have to also integrate the discharge data from the upstream dams and all, because like in Delhi you have seen, rain is not there, but flooding is happening because the water is being discharged. So any flood warning system also has to account for the discharge from the upstream dams and barrages. So until unless that is not done, sometime you may, in some cities where water doesn't come, it's okay. But there are many cities where the water comes upstream. So that part you can think of. Yeah.
Oh. Yes, sir.
Worried in, for example, Bombay Municipal Corporation, Chennai Municipal Corporation, tomorrow it will be flooding or not the city. So they can warn the people, vacate the people from low-lying areas. Climate change is a different scenario. So they are not bothered about climate change. So more important for them is the next 2 days, 3 days forecast, warnings. So that's more important. So I think I suggest that you focus more on, there are plenty of problems. Recently, I have a few days back, I read an article written by a flood expert. He told, because of the model uncertainties, data uncertainty, don't expect that you will give a warning that so and so building will go underwater. It's impossible. It's impossible to say that Bombay Municipal Corporation office will go underwater. You cannot give. Understood? So there are uncertainties involved at present knowledge. So we need to improve upon. So so you have plenty of work to do. That's what my point in improving flood warning system. NCMRWF should improve their forecast. After all, the input is from them. Your observation should improve. You have larger network. You should ensure that IITM puts that 4 radars. So then you try to merge the data together. So there are plenty of work to do. In the meantime, you do it for Kolkata. Then by that time, I think some good progress will come. Yeah. Yes, Partha.
So, okay, thank you, sir. I was also involved in these iFlows from the beginning, 2019. Now, possibly Anita did not, focus here. So, the main story of this inundation starts from the model rainfall amount. So, if the model rainfall amount is wrong, then that input goes wrong and then their inundation, etc., will get affected. Now, as of now, whether it is IMD or whether it is iFlows, they are using direct model output. There is no bias correction is happening at 4 kilometer level. That is in principle incorrect. Now, question is why we are not able to do any bias correction? Because we don't have, sir, at 4 kilometer and yeah, so sufficiently long spatio-temporal data we don't have. So she was talking about umbrella. It will never. We cannot assemble an umbrella because only in India, except few regions by ISRO, only Mumbai is having some additional rain gauges, okay, and also co-located with radar. Now, the point is, sir, they have 4 kilometer, we have 6 kilometer model, etc. The model will produce, but no model will be ever able to produce a 26 July 2005 type of intensity where in 1 hour, say, 10 centimeter, cloud burst is happening. No model. Whatever model you take from the whole world, you take. You run a cloud resolving model, it is not cup of tea of any model to generate 10 centimeter rain in 1 hour. That's what is happening. You have written and many are writing, so that's what every cities are getting flooded. Now, question is, if we want to address that, and if we want to make the inundation proportionate with that, which actually the stakeholders and society is asking, then, sir, we need a high resolution space and time, meaning, say, at least 1 kilometer in space and say 30 minutes in time rainfall data for at least 5 years. Why? Because if I have that, that will be my target. Now we all know AIML techniques, okay, we can use that, and that is also done. Literatures are available. People in Oxfords, in many other countries, Tim Palmer's group, they are doing that. So my feeling is that this is, sir, one of the way by which the model rainfall forecast needs to be bias corrected in space and time. Not just space, not just to make it a high resolution, high megapixel camera, no. Space and time. Now, this bias corrected data should go into the hydrological model what they are using and dam, etc. Then this uncertainty in the beginning will be removed. We are trying, sir, for Bombay, only for Bombay, because Bombay has, IITM has 5 years of data, and we also have co-located radar. So radar is giving 1 kilometer. Actually it gives even lesser than that, but we are taking 1 kilometer and we are 30 minutes. So, and using, so this 5, and we have these 12 kilometer models. So our target will be 1 kilometer, 30 minutes using AIML, and that data then if we allow it to go to a high resolution, this iFlows or whatever, otherwise, sir, it is just not possible.
Compared to Bombay, South India is having a lot of rain stations. Every 2 kilometers, Telangana, Andhra, Karnataka, and all these having every 2 kilometers rain stations.
What is the time?
Time is AWS, no? It has whatever.
For how many? No.
More than 10 years.
Is it the same quality?
Quality, that is the question. I
no,
answered the first
no,
question.
no,
The
no,
quality is the question.
No, no. You read Dr. Rajivan's current science paper.
No.
He himself has raised this same question that the point is that if the data quality gets
I also
regulated,
it's the same
then
thing.
Everything goes.
Yeah, so I think we can, this point is well taken. I think we will discuss it later. I think you are, after all, you are ministry people. So I think you should discuss it. But his point is well taken. You need bias correction, number one. For bias correction, you need long-term, high-resolution data, quality data. Now, you please tell Pandituri to put that 4 radars quickly as possible.
He is telling next monsoon,
Next,
we all will retire by.
no, he told today, this January, he told this monsoon. So now it is postponed.
Every time next month.
Very good. Okay, fine. Okay, I think, okay. You have finished your presentation? Okay.
Last one.
Oh.
This only I wanted to do. Last. So can we have, my thing is, one is a short-term plan and is a long-term vision. What I'm talking about climate is a long-term framework. Two different frameworks can be combined. That is my.
But you cannot combine.
We cannot combine.
That's what my point. You can have separate, you can give some kind of climate change scenarios to municipal corporation to see the next 10 years what will happen. That can be given, yes. But you cannot mix with the flood warning. Okay, fine. So thank you, Anita. It's a very interesting presentation. Do you have any further question to her? Question, comments? Okay. So next is Dr. Behra.
Thank you, Dr. Rajivan. I think you already covered the points I want to say. Before I start my presentation, I should thank the organizers to giving me this opportunity. And also congratulations to NCCR and Dr. Raman Murthy for the 25th anniversary. I will focus more on longer term scales. I think what Dr. Jera just presented is about early warning, and the lead time may be just in hours, 1 hour before or half an hour before. Sometimes that is useful, sometimes not so useful. But in terms of planning and making policies, we need long-term projections. What is going to happen in 2 to 3 years, 10 years, 50 years. And then we can develop some kind of adaptable systems that can take care of all those vulnerabilities that coastal areas will face. I think this is already taken care of by my previous speaker, Bombay and Chennai, Mumbai and Chennai, and as you know, they get flooded, especially Mumbai gets flooded every year. If you give a flood warning every year, it's okay for the local people to take some actions, but how do you make changes to those situations unless we make policies and the planning so that in future it doesn't happen so frequently? And some of the news reports already said that climate change is one of the culprits, and also the landscape use and utilization, and also the man-made landscapes. They're also culprits. We know that global warming is happening and all that heat is going into the ocean. If you don't have oceans, the atmosphere already would have been heated up by 36 degrees. And that warming is happening rapidly. There are several papers already which says that the warming trend is going to be even higher in future. And as Dr. Rajivan mentioned, that because of that warming, we'll have thermal expansion of the water. And as we are discussing for the Mumbai, if the tide water is higher than the flood water which is coming in, the flood will never get flushed out. So that we have to consider for future projections and planning. Talking about Mumbai, it's 18 million people, and we have probably 17 billionaires and 1 trillion economy. And it is very well connected with many other international communities. So all are concerned. If Mumbai has problem, then it will be a problem for New York, Tokyo, and everywhere, because all the businesses are involved in Mumbai development. So in that sense, Mumbai or any other cities in India or elsewhere are interconnected, and we need to understand and develop the right policies and planning to avoid coastal hazards. Sea level rise, we are talking about present sea level rise because of global warming, but it has been happening on interglacial scales, not only 100-year scales or 1,000-year scales, several thousands of years of scales. And many cities of India are submerged already. So historically, we know that there are several cities on the coasts. They are now submerged. And many projections are saying that most of Indian cities will be underwater in 100 years. So do we have to take that as it is, or we have to also consider how it is going to change with different scenarios? We just heard about the different ways of how the landscape, bathymetries, and the land use and other things are affecting the floods. So in that sense, if you just project what is going to happen based on global warming, I think we are not going to do a good job. We need to understand how the global warming, together with the climate variations and extreme events and the land use, going to change the future scenarios. And to do that, we need to monitor and also predict, and monitoring already happening. I'm talking in terms of global oceans. Of course, coastal monitoring is important. We already heard about that. I'm talking about the global monitoring because in addition to the tropical monitoring, which has been enhanced in recent years, we still are far away from understanding what is happening below 2,000 meters and what is happening in the polar regions. And those are very important for like sea level rise because of ice melting, because of thermal expansion, and most importantly, I think the dynamical aspects, which often we miss. The next thing is the modeling, and from the toy models developed by Suki Manabe, Cork-Bryan. Suki Manabe got the Nobel Prize for that. From that scale, we have already reached very high resolution global model for projecting climate for 100 years. However, we have to take the model results with a pinch of salt because we are still developing and they are not so accurate. We need to further understand and also include them in the models. This is one of the studies from my colleague, Dr. Yamagami, who compared several CIMI-5 and CIMI-6 models, and he found a lot of biases in SST, in rainfall, and then he tried to understand if he can improve the SST, which is causing biases in the rainfall, by increasing the model resolution. So MIROC 6, which is going to the CIMIC 6 archive. In addition to that, he made his own archive by increasing the model, ocean model resolutions to 1/4 degree from 1 degree. And he found better simulation with that. And with that also he found that he could simulate the west coast rainfall better. It is very important when you are doing the Mumbai rainfall projections and predictions. So in terms of that, we need to improve the fidelity of the models, improve the resolutions, improve the physics, and include more data by assimilating them, whatever we have now. Talking about the climate change and climate variations, and I think Dr. Rajivan mentioned that, in the last 100 years, if you take 2.5 or 2 millimeter per year sea level rise, maybe it is about 20 centimeter now, 25 centimeter. But one El Nino event or one Indian Ocean dipole event can cause a sea level variation of 24 centimeter, which is equivalent to what we have seen in terms of climate change in the last 100 years. So we cannot neglect these kind of climate modes, El Nino, IOD, or even monsoon. We cannot neglect them, and we need to predict them well in future so that we can combine the climate change effect with the climate variation effect. And then on top of that, we have to also understand how intense will be the extreme events like cyclones and how frequently they will happen, so that we can also project those things on top of them. And then we make different scenarios. Okay, we have a high tide, we have a climate change, we have El Nino, and at the same time we have a super typhoon. Then how much flooding we should expect, and what kind of mitigation measure we should take care. talking about the El Nino and Indian Ocean Dipole, we need to predict them, and this is another ball game. So we are also developing climate prediction systems. One of the systems we are using is X Frontier model. It is a very good model. We have validated them, validated the results very well. It's predicting El Nino and dipole and monsoon well. This is the prediction given in February for the El Nino, and we are seeing the El Nino now. It also predicted a positive Indian Ocean dipole. It has not happened so far, but it predicted a quite normal monsoon rainfall, and that's what we are expecting now. Although several models said it will be a drought, but we are saying it will be quite normal or slightly below normal, because the model was not predicting a very strong El Nino. The El Nino is going to decline, I think, now. But if Indian Ocean dipole happens as predicted, monsoon will be okay or slightly above normal. We are also talking about the digital twins of the ocean and atmosphere, especially the digital twins of the oceans in the ocean decade we are having now. Challenge 8 among the 10 challenges taken in ocean decade initiatives is developing digital twins so that we can have a digital platform which can provide scope for many stakeholders and many users from different areas of the world. Considering the digital divide, you have very strong digital divide. Some countries are well ahead, some countries are not so well ahead, but we are trying to develop a interface, this kind of digital interface, which can provide information for all users in the world at a resolution which is possible considering the present computer systems. We are thinking of 200-meter ocean, at least half kilometer to 1 kilometer atmosphere model, so that those information can be useful using the digital interface we are developing now. The idea is to make a 4-dimensional interactive virtual Earth. At the moment, it is not 4-dimensional, not interactive. It's just 2-dimensional, but we are trying to make it more interactive by providing scope to digitally downscale the predictions for desired regions, and then make it 4-dimensional by including jet direction and also time. So by doing that, our idea is like we are in society 4 now. From hunting and gathering community of society 1, we have reached society 4, where we have all the digital systems and cloud systems. But we are moving towards society 5, I think, a more generative AI, which will kind of create system to interact by themselves. So with less human interference, interacting among Internet of Things. And by doing that, we will reduce the human errors in the system. At the same time, we'll make it more automated so that even if no human is there, this system will work 24 hours, 7 days a week, 365 days in a year to provide early warning to anybody, anywhere. That's the idea. I hope it will happen in next 10 to 15 years. I think the quantum computing is going to play a big role in that. It's coming up. Everything will change. Once quantum computer is available, everything will change. The way we are coding now using Fortran will be obsolete. We have to use different techniques. Numerical techniques will not work. But once we have that, then the system will take care of many things based on the observations and the knowledge we have developed so far. However, our idea is the society 6 and 7, especially for oceanographers and climate scientists. I think if the projection is what is going to happen, probably you have to think human society underwater or in another planet. So in that sense, society 6 and 7 will be more advanced than what we are imagining right now. Okay, with that, I come to the summary of my talk. I think I'll emphasize the last point. The state-of-the-art climate models are doing a good job, but the uncertainty in the future climate remains. There is a need to combine the effects of global warming, climate variations mode, extreme events, land use and urbanization to correctly estimate the future changes in sea level and the impact on coastal regions. I'll stop there. Thank you.
Thank you. Thank you. Thank you, Dr. Bhaira. Some questions to him.
When are you talking of digital twins, especially, for oceans, we really, have not much of knowledge about, the ocean column because of lack of observations. Mostly the observations are satellite driven. They are confined to surfaces only. So what is the kind of, trends you see in terms of data gathering as far as the ocean column is concerned?
Ocean colors.
The ocean column.
Column, yes. Below 2,000 meter, I think, up to 2,000 meter, we have some kind of, Argo is doing well now. So now people are talking about deep Argo and also biogeochemical Argo so that we can take all the observations. And those are very expensive compared to what we have now. So we cannot have so many of them. But eventually, I think in 10 to 20 years, we will have a good cover throughout the globe. And the second problem what we see is undersea ice. Taking observation undersea